Hello world, my name's Nigel. I want to offer something to all of you. I'm going to show you a little presentation, and I want you to think what's going on. So without further ado, I'm going to give you this presentation. There, you can see a spark. That spark is equivalent to about 300,000 electron volts. Look at the size. It's cold, doesn't burn the hand. This is new energy. This is PCAMs. I wrote this presentation as an investor brief, and I've given this brief to many people over the last month or so. I'm not happy with venture capitalists or banks. All they want to do is take the money. So what I'm doing, I'm now offering this to everybody, to humanity as one. We need to have a think, and I'm going to ask you a couple of questions. Humanity as a species has come to a crossroads in its own existence. We've raped, we've polluted. We've dug holes in it, we've dug up, and we've destroyed the very best that this planet had to offer. We're killing the planet. There are no second homes at this time. So the crossroads we've come, do we continue in this annihilation of our planet, or do we take another course? And if we make our next decision wrong, what do we leave our children? If we stay on the hydrocarbons and continue to pollute, if we continue to dig up the rainforests and destroy every habitat there is on the planet, what are our children going to write on our gravestones? Cheers, Mum. Cheers, Dad. Thank you for the rubbish tip that you left us. So what we now choose to do today within this brief will form the destiny of the species, of all of us, not the 1%, each and every one of the 8.1 billion people on this planet can have access to what I'm about to give you. The discovery of PCAMs is unprecedented before humanity. It forms a once-in-the-lifetime opportunity for the species. It's not for the 1%, it's not for oil companies, it's not for governments, and it's definitely not for banks. So what is PCAMs? Well, in this image, you can see two photographs, one to the left and one to the right. I had an electrical engineer put together some equipment for me, and this is what it actually looks like, is the physical box. So we can have no one turn around and say the box doesn't work. Okay, let's get that cleared up from the start. And the photograph right at the start. Don't tell me this don't work. So what is PCAMs? PCAMs is a photonic catalytic amplification matrix. It's a generation of synthetic high energy photons that are then post-processed to produce an abundance of energy. And I do mean abundance of energy. But before we have a look at the PCAMs, we have to look at our problems that we've created ourselves. And one example of the myriad of problems is lithium. Lithium is a bomb. Let's not mess about. Lithium is a bomb. If you puncture a lithium battery, it'll explode. You put it in water, it'll explode. You overcharge it, it'll explode. You charge it too fast, it'll explode. It's prone to erosion and bloating, and they cause explosions, and it is highly toxic. So what are we doing? I refer to this as a bomb factory. I just picked Tesla because Tesla is the name that everybody knows, but any EV company, they're all the same. So the Tesla automotive company takes a standard LiPo cell, the bomb, and then multiplies it by many thousand, say 10,000, and just makes a bigger bomb. The problem with this bomb is now has a wheel on each corner and can go anywhere, and it's still a bomb. That there is a Tesla motor car. That is what LiPo looks like when it goes off. That's real. I didn't make the photograph. I didn't build the car. I didn't put LiPo in there. I'm just presenting you with the fact and the truth. Pecans does things a little bit different. It uses silicon and yttrium. Both are naturally abundant. Both are inert and non-toxic. And people say, well, have we got enough silicon? I say, bucket's full. We've got a whole desert full of sand. Don't be say you need special silicon. It's a lie. Yttrium, we have mountains of it. There's one particular country, Romania. In the northern Romania, they have polymetal ores in mountains of it. Mountains. Now, I've had to hide off some of the technology because there are thieves out there, particularly the US. And the theory was, can we take a current technology, change how it actually works, and make it do something totally different? So that was the thinking. So I got a handful of engineers and said, I want you to do this with that and see if it does the other. That was the process. And after a lot of explaining, we put it together and they constructed a device and they put in 5 watts of energy on one side and got 28.8 on the other. Now, when I went to school, 28 is bigger than 5, which means we got out more than we put in. Therefore, the laws of entropy, you can't have something for free and you can't have more out than you put in, are a total lie. That means the whole construct of the thermodynamics principles, which has driven this world for at least the last 200 years, was built on falsity. It was a rabbit hole. So how does PCAMs work? PCAMs is like a card, a very thin card, and like a pack of playing cards. So if you have one card does 1 unit of energy, 52 playing cards in the same box produces 52 lots of energy. And then you multiply that out. That's the simplest analogy to how a PCAMs is constructed. So having proven the theory that we could produce 28 watts, and by the way, between going to print of this video and what I received this morning, my engineers have now doubled that power to a point where they've now got 52 watts from the same 5 watts. So that is really impressive going. I asked my engineers, how small can you go with this? And I then went back to the manufacturer and said, can you make small things of A, B, and C, and 1, 2, and 3? And they come back and said, yes, we can make them sub-millimeter size, like 0.7 by 0.3 by 0.6 millimeters. That's very, very small. And I said to my engineers, if you engineer that in this shape, how small can we actually get it? So they said, well, we can make a card. Remember the playing card? We can make one of these. That's a mere 2.4 millimeters thick. And I went, that's very good. But we need all the space and what we see there. I said, well, okay, if we've got that as the principle, and we now make our pack of playing cards a bit bigger like this, and we say it's like 320 millimeters long by 160 millimeters wide by 10 millimeters thick, which is 5 playing cards, 5 layers, we end up with something that's 10 millimeters thick. That was the idea. And I went back to the manufacturers and provide your data on all of those figures. And we ended up with a value of 83.4 watts for 10 millimeters. That's the thickness of your finger. It's not 83 watts one off. It's 83 watts for a very, very, very long time, about 100 years. So I said, if we take this, can we now put 2 or 3 cards together and make it a bit bigger? So each of the little squares shows it's 83 watts. So if we put 3 of them together, we end up with a layer, which is 960 by 160 by 100 mil. there's your box, and it produces 2.5 kilowatts of energy. 2,500 watts of energy every hour, all the time. So it will do this day in, day out, and 2.5 kilowatts is an average small home. So my engineers tested it out and said, yeah, all the figures are right, all the values are right. What else can we do? I said, well, if you take this and you tweak it a little bit, you can kind of make something that looks the same size as a small wall cabinet. So each one of the units was 2.5 kilowatts, and then we put 10 of them on top of each other. So we ended up with a device that was about 960 millimeters wide, a meter high, and 160 mil deep on the wall, producing 25 kilowatts. That's enough to run any house with ease. This intrigued the engineers, and they said, well, okay, let's go for the meter by meter, something the same size as a domestic refrigerator. So we did. As you can see, we've got 5 blocks of 25.29 kilowatts each, and it gives us 126.45 kilowatts. That is enough energy to run a small village, because it produces this energy not once, but continually, every minute of every hour of every day of every year. That is a phenomenal amount of energy for you. Let's have a quick summary of what we've got. We've got PCAMs. We know it's card-based, and it's 320, 159 by 10 and produces 83 watts. And if we put 3 of them together, we're going to have 250 watts. And if we stack 100 of them cards, we're going to have 25 kilowatts. And if we put 5 cabinets together, we get 126.45 kilowatts per hour. Now, PCAMs runs 24 hours a day. So if you go 24 times 126, you end up with 3 million watts of energy every day. That's 3 million watts for free after the cost of the box. It's infinitely scalable. So whether we have it as 1 meter, 2 meters, 10 meters, half a kilometer, it doesn't matter. Each one just bolts together or automatically connects together and amplifies the next range of power. Let's have a look at what we call, what can we use today and what we can use tomorrow. You know, like wecompare.com, we're doing a power density compare. So on the left, I've taken some storage devices such as nickel cadmium, lead acid, nickel metal hydride, and lithium. So as technology within inside the battery storage world continues, we ended up with lithium, which is producing about 265 watts per kilogram of lithium. Now, with inside a lithium battery, it's not all lithium. There's paper, there's materials, there's plastic. So the amount of lithium is not 100%. PCAMs, using the same principle, 1 kilo of silicon and yttrium produces 126.45 kilowatts. We only use about 50 atoms of yttrium per cell. 50 atoms. You can do that 100 times on a pinhead. But it means that a PCAMs unit per kilogram is 477 times more efficient than the bomb that you drive around in a car. That's phenomenal. Why have you not known about this? You've got to ask that question. It's no good building something if it doesn't last for a long time. It's not an IKEA product. You build it once, it falls down the next day. It's not buying a Ford and you drive it for 22,000 miles and the engine drops out. It's not a set of clothes that you put it on once and the sleeve falls off. That's called false economy. It's build a box and it lasts. It doesn't give out on you. So I went back to the manufacturers and I asked them, of all of these components, which one is the weakest link? Which is the weakest component? And the company says, it's this item here. I went, okay, how good is it? And they come back and said, well, we can guarantee that bit of kit for 25 years. That's without us having to pay anything to anybody because it went wrong. 25 years. And the manufacturer says, well, actually, it's 25 years on the guarantee, but the mean time between faults, the MTBF, mean time between faults, is about 50 years, if not longer. So we said, okay, if you've got 3 million watts per day, and we multiply it by 365 days in a year, and 50 years for the mean time between faults, we end up with 54 gigawatts of energy before it even makes a fault, if it makes a fault. The realistic life is more like 100 years. So that's 2 times 54, which gives us 154 gigawatts of energy from this box before it might decide to give up and die. That's if it gives up and die. And in 100 years, how far can you push that technology to make it better? Think about it. Who's been lying to you? So what's it worth as a costed value? Well, I wrote this brief for the European Union. So all the figures are displayed in euros, but you can do the same calculations for any country that you're in and just substitute and you'll get a value. So in Europe, the average cost of 1 kilowatt of energy is 30 cents. Now, if we build our Pecans box at a 1 meter cubed and then applied the same 30 cents for every kilowatt that it produces at 3 million, it gives us 9,000 euros per day of producing energy. 9,000 euros per day. That means in a month, it will produce more than €250,000 euros. It's 270,000 euros of energy per month. This will generate. That's phenomenal. So if the EU's average bill is 350 euros across different countries and whatever, 350 euros, and we divide that into the maximum production of a 1 meter box, we end up with the power being generated by PCAMs to be 771 times cheaper than anywhere in Europe. Now, if you convert that into cents and euros, it's 0.0004 of a euro, or 4 thousandths of 1 cent for a kilowatt. Can you see how much you're being robbed by the energy companies? 771 times cheaper, not half the price or a quarter or a tenth, 771 times cheaper. So how clever is this box? Where can we put it? So we have a look at a thing called diversity, where we can put it. As we said, we can have it as a single box, like the size of a pack of playing cards, right the way up to something the size of a refrigerator and beyond, and anywhere in between. Houses don't come in the same size, so we have a 2-bedroom, 3-bedroom, 5, and so on. And we can build a box that makes 6 kilowatts, 12 or 24. That means we can supply any house. So if you look at Europe, there's 580 million people living in Europe. If we have mum, dad, and 2 kids, a cat and a dog, we end up with around about 100 million properties. So we can provide domestic energy to 100 million properties with ease. With ease. If we can do houses, then surely we can do commercial properties. We can do Costco, Target, Woolworths, Tesco's, Lidl, the shopping malls, all of them. We can provide all the power. Now, when you go in a shop and you buy something, say you go into Lidl and you go and buy yourself a frozen turkey because it's coming up for Christmas, part of the cost of that turkey was keeping it in the freezer. Running the freezer costs you electricity. But if a commercial property is driving on a PCAMs, then they're not paying for electricity. Therefore, the cost of the turkey drops. So all commercial properties that run PCAMs means the cost of what they sell products reduces, which is better off for everybody. You're the one who's got to go and buy your turkey. So use one, you get, why haven't you got this installed? The shops say, we want this installed, so we're not paying a fortune to the taxman and the electricity companies. You can't meter this. If there's no meter, there's no bill. If there's no bill, there's no tax. It's simple as that. So if we can do houses and we can do commercial properties, we can do the source of generation, the products, we can do the industrial. We just make the box bigger, 2 meters, 4 meters, 6 meters, whichever is necessary. So we end up with 0.6, 1.2 or 2.4 kilowatts for an industrial property. The biggest cost in producing something is the amount of the cost of energy to do so. So if we remove the cost of energy to produce a product, it's cheaper. If we've reduced the cost at the point of sale in the shop, it's cheaper. If we reduce the cost within inside a home for energy, it means the homeowner actually has money in their pocket to feed themselves. And that money goes a lot further. This is where PCAMs goes. We can make portable units. As I said, we can go anything from a pack of cards and a lot smaller to as big as you want. And in Europe, there's another 10 million opportunities for people who want portable devices. They've got the mobile homes, they go camping, they have a boat, whatever, and they just have one thrown in the boot of the car when they go out for a picnic. Portable units. The emergency services, this is where I originally went for, because I'm a good-hearted Samaritan type people. I hate seeing devastation, I hate seeing death. And when you have problems like what happened in Haiti, and when you have earthquakes and total devastation, the biggest problem the emergency services have is we can't provide power to make clean water, electricity, to provide emergency services. PCAMs looks like a brick, the same size as a domestic fridge. How many domestic refrigerators can you put in a 40-foot shipping container? Connect them all together and you have power for a city. It's extremely light. It means you just hook this up underneath a helicopter and you drop it right where the disaster is. That's the brilliance of PCAMs. We've already had a little dig at the EV cars. So what we can actually do for new EV cars or for the new PCAMs car, you can take the PCAMs and you can make it very, very thin into the base of the car. It will also retrofit. That means we can take out the oil burner on the front and the gas burner on the front and the diesel burner on the front and the petrol burner on the front, replace it with a PCAMs unit and a powerful twin stator motor and attach it straight to the gearbox. We can retrofit every single car in Europe. The motor is that good, you'd scrap the car before you scrap the motor. That's 250 million units worth. If we can do cars, we can do trucks. Now, I actually know a trucking company and I spoke with them at length and they are quite worried where they're going. They were in Australia and they use long truck. So you have like 4, 5, 6 wagons on the back of it. They're long. They call them road trains. And a particular driver said to me, I spend $120,000 on fuel each year for one truck. He drives 10. He spends $1.2 million every year just driving from A to B. If he put 10 PCAMs units in here, he's just saved 1.2 million. Every year, it'll do it for free. Now think of the massive carbon reduction that's going on. Better still, think how he just shafted the taxman. You can't meter it. You can't charge it. If we can do cars and we can do trucks, we can do trains. We can take off the big lumpy bit at the front. We can put PCAMs under the carriage and we can drive each wheel. So instead of having one big motor, we have lots of little ones. It makes it highly efficient, very, very quiet, with zero pollution. And you don't have to fill it up every day. You have a public transport system that costs almost nothing to run. You don't have the £2,500 season ticket because you're not costed any energy. It's so cheap, you just get on it and go to wherever, which is congestion removes. It's there, PCAMs solves the problem. If I can do them, I can do them and all. Is all that is a great big diesel engine, which spins a big motor, makes electricity, which goes to an omnipod, which is like a donut-shaped thing, that fits underneath with a propeller in it, an electric motor. So they go from diesel to electric, from electric to electric motor to motive force, and the ship goes through the water. So if we put PCAMs in one of these, you can get rid of the great big diesel burner. We can get rid of the great big electrical generator and drive straight to the omnipod. So there's a massive reduction in weight in the vessel and there's no pollution. You don't have to fill it up. You know how many tons of fuel one of these goes through a year? Think about how many tons. It's about 100,000 tons of fuel. Think of the cruise liners, Caribbean cruise liners. They have a fuel bill annual of $100 million. Just swap them all out for PCAMs. Who's ripping who off on the fuel game? If we can go big, we can go small. We can use a special material, a new material. Go and look it up, do your own research. It's called transparent aluminum ceramics. It's thinner than the width of the hair. So I can make things so small. I can make them so they fit in smartphones. They fit in tablets and laptops. Every time that you plug your smartphone in and charge it, it costs you €1. That's a round figure. There's 5 billion of them on the planet. So that's 5 billion euros every single day just charging the devices up. I haven't added the laptops or the tablets. That's every single day, 5 billion euros is wasted. PCAMs will fit in a phone in one go and it will last a lifetime. Most of the time people dispose of their telephones because the battery is defective. And the manufacturers such as Apple and Samsung have made them sealed for life so you can't get in them to swap out the battery because there's nothing wrong with the phone. It's just a goddamn battery's gone tits up. Apple and Samsung and Huawei need to apply this technology now to the phones. That is an absolute must. We can go even smaller. My engineers have actually built a supply that is down in the 1.5 watt range, but persistent for 100 years. So we can actually make a pacemaker that runs on a PCAMs. And when the person dies, you'd have to take their heart out and hit it with a big stick to put the heart out. It's that efficient. Because we can make things so small, another group of people on this planet suffer from what's known as kidney dialysis. You have to go and have their blood cleaned. And it's a big, bulky device. The PCAMs will allow that device to be reduced and become portable with the person. So why they still remain on the need for a new kidney, they don't have to go to hospital twice a week or 3 times a week and hook themselves up to a set of tubes to have the blood cleaned, because they're getting it done all the time. If you look in the picture, that is an ICU bed, an intensive care unit bed. How many watts of energy are being consumed with all those electrical monitoring devices and triggers to keep that person alive? And if someone went, bye, turn the light off, you've got a dead person. PCAMs is built into the bed itself. If you turn the power off, it's not a problem. PCAMs is a lifesaver. As I said, I'm humanitarian. I'm not here for profit. I'm not here to give pain and suffering. So let's compare what we've got. If we take PCAMs versus solar, because the big solar, let's all buy solar. It's the best way of doing things. And solar panels are an odd shape, but if we now cut a little bit off, make a 1 meter, and we can evaluate at 1 meter. So the very, very best solar panel is about 400 watts per square meter. 400. PCAMs in its low density, which I call its hammer and chisel model, its very first one, like carving a stone wheel, this is the first generation, is 5,058 watts per meter. That's an awful lot more. Solar, optimal is 8 hours. And I say optimal in 8 hours because it's relying on a good day with the handbrake off going downhill and hoping that there's no clouds and there's no smog and there's no dirt and films on the solar cells. Then, and only then, will you get 8.2 kilowatts. But that's only for like the first day, because solar degrades very fast. They don't tell you that, do they? So when you buy this system and you install it and they show you all the meters, there you go, 3.2. And they walk away and you come back 6 or 7 weeks later, it says 3.1. And you go, oh, I've got to go and clean it. Oh, it must be clouds, it must be smog. And then you come back, it says 3, then 2.9, 2.8. It's degradation of the system. It's false economy. Okay? PCAMs, on the other hand, it'll produce per meter 121 kilowatts every hour, every day. It doesn't matter about the sun. It doesn't matter about smog, cold. It doesn't bother it. So that makes PCAMs 38 times more efficient than the most efficient solar system. So who's robbing who? Who's scamming who? Let's have a look at hydrocarbons, you know, gas burners. Well, there is a particular if we break them down, you've got petrol, propane, methane, not methane, butane, and a lot of these hydrocarbons. And one of the high-end, high-octane hydrocarbons per litre will give you 10 kilowatts of energy. Once it's gone, it's gone. So in 1 hour, it produces 10 kilowatts, 1 hour. doesn't produce it again. PCAMs on the other side, on the other end, in the hammer and chisel model, will produce 5 kilowatts per hour. And again, and again, and again. Every hour it produces the same 5 kilowatts. So in 2 hours, it's broken even. On the third hour, it's in profit. There's really no comparison, but I had to make numbers so you all use this money stuff. So if you get 10 kilowatts per hour for 1 litre, you need 24 litres for 1 day. Therefore, you would need 33.5 euros per day, non-recoverable, just to break even. Now, as I said, PCAMs is self-perpetuating, but in order to do a comparison, I had to produce a value of the internal energy used, the bit that it needs to drive itself. And that equates to about 2 euros. It's 2 euros and 16 cents on internal self-powering. So it don't actually cost nothing, but I've got to give a number. That still makes PCAMs 15 times more efficient than the most efficient hydrocarbon that you can't buy. You get the cheap stuff, you get the nasty stuff that doesn't produce a lot of power. And they're charging the earth for it. In fact, the taxman charges the earth for it, and you pollute the earth with it. So that's hydrocarbons out the window. That's solar out the window. Let's have a look at a few more. Let's take it on a whole Earth scale. PCAMs is the only process that functions irrespective of weather patterns. Doesn't matter. If you've got a solar farm, one good hailstorm, one good storm of anything will destroy that place. And you've got no solar farm. Well, okay, you say we have a wind farm. Turn the wind off. You've got no wind farm. And if it's too windy, you've definitely got no wind farm. Well, we use a hydroelectric dam. Turn the water off. Go for a drought. You've got no hydroelectricity. And if it rains too much, you've got no hydroelectricity. Well, we use nuclear. Well, go and have a look at Chernobyl. Go and have a look at Mile Island. Go and have a look in the UK at Windscale. Go and have a look at in Japan, Fukushima. What happens when mankind gets it wrong with nuclear power? You don't just get no electricity, you get millions of people dead. And millions and millions and millions of square kilometers of land destroyed and made uninhabitable from the use of nuclear power. That's insanity. That's absolute insanity for a species to dabble in nuclear power when they don't understand how it works. However, PCAMs, it's not nuclear. It produces zero waste, zero noise, and zero pollution. It's not affected by wind, hail, snow, rain, earthquakes. Doesn't bother. It's a perfect energy supply for all the needs of every single man, woman, and child on this planet. They all deserve to have PCAMs. The oil industry, the hydrocarbon industry, the coal industry have had their day. They have raped the planet 1 year too many. And they've extorted from the species $1 too many. Because now PCAMs is going to as many places, if not every single place on this planet, as fast as my factories can build them. And I'm not going to charge an extortionate price. I'm going to charge a break-even price. And I'm not even going to get you to pay that. I'm going to get you to pay it over many, 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 many years, interest-free. So you get the power on day one. You've been paying a bill for months and months and months. So how about paying 1/10 of that bill for a short period of time? say over 10 years, and you've got a box that lasts 50 or 100, you win, I win, the planet wins. Who's the loser? The oil companies, the polluters, the energy companies, and the taxman. You cannot meter PCAMs. If you can't meter it, you can't put a bill on it. If you can't put a bill on it, you can't tax it. It's that simple. What's it worth? As I said, done for Europe. Energy consumption for 2020 was 239 hectowatts. Hectowatts is lots of noughts, as you can see. So if we convert that to kilowatts, it's still 239 with an awful lot of zeros. Now, if we divide that out by the, we multiply it out by the third of a euro per kilowatt, we end up with a staggering 717 billion euros every year for a product you can't recover. All of that money, all of it, is going in the pocket of those who produce the energy. And they produce the energy by raping the planet. The planet gave itself for free. No one can charge for it, but governments do. You're the only species who have to pay to live here. When you pay a government that doesn't even own the planet, you're getting conned terribly. Now that's just for Europe. Now you multiply that by the 7 major principal continents, and you end up with 4.9 trillion euros spent in energy. And all of that is pouring into some pocket of somebody who produces the black stuff out of the ground. It's terrible. Absolutely terrible. It's a disgrace. It's a crime against humanity. Now, if you wanted access to this technology, we have a thing called an ROI, return on investment. What would you prepare to put in the pot in order for me and my team to build these? And then we can get them out there. What would you put in the pot so we can get it done? It's a question you've got to ask yourself. Okay? Think about that one. So there is the brilliance in PCAMs. And please, it's the last time for humanity. The very, very last time it's being offered. You choose the wrong one now, and your species will be dead within 30 years. I kid you not, each and every one of you. You waste this opportunity, and your children will be cursing you until the day they die. So why don't you take this opportunity to get a copy of this video, sit down, watch it 2 or 3 times as a goddamn adult, learn the words in it and the phrases, sit down with your children and explain to them what you are going to do for their future. Then ask your child what they would like for Christmas. Think about it. That's what one looks like. It's about a car battery size, but only 1/3 of the width of a car battery. So I put 3 of them together, it will produce about 500 watts all the time, non-stop, forever, 500 watts. Well, forever, about 100 years. If you take the Tesla car, back to him, sorry, sticking a knife in his back yet again. For a Tesla car to do 100 miles, it needs 34 kilowatts. Therefore, for 1 mile, it needs 340 watts of energy for 1 mile. This, the size of a car battery will do 500 watts. So it will do everything that the car needs and still have more. And at the end of the day, you don't have to plug this type of car in. You never have to plug it in. It makes no pollution. It costs nothing to run other than the cost to build, and it's not expensive to build. So who is robbing you? It's not me. I'm doing my best to get this to you, but I'm being blocked every possible direction and stopping me getting this to you. So I'm hoping that for my Christmas present, a few million people get to see this. That's where I'm going with it. Now, you're all going to have questions to ask, and I know you all going to have questions. So I've put an email address up there, and I get a lot of emails, and I scan through the emails, and if I see a lot of repeat questions of common questions, and I won't answer to every goddamn one of you, I'll make another video answering your questions. That's what I've got to offer. That's available today. The test box has been built. The test values have been produced. They have been ratified by engineers and other professors. It's real. It's not a media scam. It's not a government cover-up. It's here today for you. All I need is humanity's help to make it work for each and every one of you. So that's where I'm going with that. I hope you found that interesting, and I hope you use the information I'm giving you. So at that, I thank you for taking your time, for sitting down and listening. And please, if you've got any questions, let me know, and I'll do my best to answer them as a collective of one for the species. Okay, thanks very much.